Okay, so you should have just spent the first several minutes working on your test review by yourself. So you're going to use this as kind of a way to check and make sure you have the right answer, or go back tonight and study for your test on Thursday. So number 1, an air conditioning technician charged Kaysen $165.50 to repair his air conditioning system after 5 hours of work. The technician charged the same rate for each hour of work. Which diagram represents the constant rate of change for this situation? Okay, so he charged $165.50 for 5 hours. So we're trying to see how much did he charge for just 1 hour. So that's your proportion. So already we can eliminate A. Because he charged $165 for 5 hours of work, he didn't charge $165 every single hour. So that one's out. Same thing on B. For 1 hour, $165.50. 2 hours, $165.50. Not going to work. He charged that much total, not every single hour. Okay, so let's go ahead and solve this proportion because we want to figure out what he paid each hour. So we can cross multiply. So I'm left with 5x equals $165.50. Okay, so then your last step is to divide by 5, divide by 5. Those cancel out, so I've got $165.50 from 5. So 5 can go into 16 3 times, so minus 15. That gives me 15 again. So 5 will go into 15 3 times. Bring that decimal up. So minus 15, that's 0. Bring that 5 down. So I'll go in there 1 time. Minus 5. Bring your 0 down, 0. So $33.10 is what he charges per 1 hour. So we're already down to 2 answer choices anyway. So $33.10 is what he paid for 1 hour. So the only difference between these two is this is saying he's paid $33.10 per 1 hour, $33.10 for another hour, $33.10 per 1 hour. And that's what it was saying, right? Each hour of work he paid the same. So he didn't pay $33 for 5 hours. Not a good deal. He paid $33 for 1 hour for each hour. Number 2, the table shows the time it takes a prototype airplane to travel different distances. So we want to see what is the constant rate of change in this situation in miles per hour. So we want to see what the change is in our y value and the change in our x value. Remember, this is always your x, this is always your y. So let's skip the 0 because that's not really going to help us. So let's look at the difference between 23.6 and 17.7. So 23.6 minus 17.7, that's going to give us 5.9. And then just to see, 29.5 minus 23.6. And 0. So 5.9. So 5.9, 5.9. The change over here looks like 24, 30 to 24, 6. So we'll use these two. The rate of change, so your change in y, 5.9, over your change in x was 6. Obviously, that's not an answer choice, but we have our change in y over change in x, so we want to see what the miles, what the rate of change would be per hour. So notice your time up here is going by minutes. So if we want to find 1 hour, we're going to need to make it match this chart. And this is going by minutes. So 60 is what we need. 60 minutes are in 1 hour. So same thing, we want to cross multiply. So I've got 60 times 5.9. So let's see, 60 times 5.9. I'll have to come over here. Well, let's write our equation. So 6x equals 5.9 times 60. Okay, so 354. And then my last step is to divide by 6. So 354 divided by 6. 6 can go into 35 5 times. That'll give me 30. So 35 minus 30 is 5. Bring down your 4. 9. 59 miles per hour. Okay. Number 3, Jeff drove a total of 1,260.75 miles in 3 days. What was his average distance in miles per day, per 1 day for the trip? So we can set up our proportion first, and we can see he traveled 1,260.75 in 3 days. So if I've got miles over days, I want to keep that same pattern up on the other side of my proportion. So miles over days, and I don't know how many miles in 1 day. Okay. Cross multiply 3x, 1260 times 1. Doesn't change, so now I just need to divide by 3. I'm taking this the long way. I know you can probably see that you can just divide that. I'm just taking this long way just so we can practice doing these proportions, just so you know, okay? In case you're wondering why I'm doing all of this extra work. I'm going to come over here and do this. So 1260.75 divided by 3. So 3 can go into 12 4 times. So minus 12 gives me 0. Bring your 6 down. 3 can go into 6 2 times. Minus 6. 0. Bring your 0 down. Don't forget to add that decimal there. So that's what that'll be. Okay. 0. So then let's bring our 7 down. So 3 can go into 7 2 times. 3 times 2 would be 6. Minus 1. And then last step, we want to bring that 5 down. 3 can go into 15 5 times. So my answer should be 420.25. Don't forget, when you have these, fill in the blank or fill in the bubbles to bubble it. And bubble it right, not like I just did. Bubble it the correct way. Okay, number 4, Patrick bought 2.7 pounds of T-bone steaks for $36.18. How much did he pay per pound, per 1 pound for the T-bone steak? So he bought 2.7 pounds for $36.18. Okay, so the words that we know, we've got money over our pounds, LBS. That's going to stand for pounds. So let's put what we know. We know that he paid $36.18 for 2.7. What we don't know is how much he paid for 1. Again, cross multiply. So 36.18 times 1 is 36.18. 2.7x, 2.7 times x. And then your last step is always to divide. Okay, I'm gonna have to get a separate sheet of paper. Okay, so we've got 36.18 divided by 2.7. Remember, if you're dividing by a decimal point, you want to move the decimal that's on the outside number however many times it takes to get to be a whole number. In this case, it just took 1. So I'm going to do the same thing to the decimal that's on the inside. I moved it 1 spot. That's my new decimal point. So 27 can go into 36 one time. So minus 27 give me 9. 27 can't go into 9, so I'm going to bring down the 1. 27 can go into 91 3 times. Let's check. Yep. So minus 81. So 0, 1. Let's bring our 8 down. So 108. 27 can go into 108. Let's try 4. 8, 9, 10. Yay, perfect. So 13.4. Is that an answer, Joyce? Yay! So $13.40 for 1 pound of steak. Number 5, Gene was pricing ingredients for a recipe he was planning to make for a dinner party. The store sold 4 different brands of the same type of product. Which statement about the unit cost of the different brands is true? So what we're going to have to do is find the unit cost for each brand. So we're going to have to do it 4 times. I'm going to set up one proportion, and then we can kind of solve the rest of them that same way. But we want to do same thing. We've got our money over our ounces. That's our words. What we know is for the first one, $2.94 for 9 ounces. So we want to see how much for 1 ounce. So we can cross multiply on this. So 9x equals 294. So basically what you're doing is you're just dividing. So 294 divided by the number of ounces, 9. So 2.94 divided by 9. So 9 can go into, it can't go into 2, so let's put a 0. I'm going to bring that decimal up. 9 can go into 27, 29, 3 times, and that would give me 27. 29 minus 27 would be 2, so 24. And 9 can go into 24 just 2 times. So minus 18 gives me 6. And then 9 can go into 66 times. So minus 54. And I'm out of room. But, so I'll just leave it like that, 0.326. So for brand 1 per ounce is